Welcome back to the deep dive. If you've been following along, we've made some really excellent progress scaling your digital capital.
We have. We started with the foundation, right? The digital balance sheet, the ROE framework,
Then we went out and hired the talent, the synthetic developer, and the researcher.
and they are ready to work. They've got the skills, the tools.
Yeah.
They're standing on the job site, ready to build. But now they're looking around and asking a pretty crucial question.
Where are the materials?
Exactly.
And that question is the perfect transition into part 3 of our series, the infrastructure. Today, we are tackling chapter 5, which the source material calls the data substrate.
And the metaphor the book uses here is, well, it's perfect and a little painful.
It really is. Right now, for most of you, your data isn't some structured warehouse of materials. It's just a pile of lumber.
A giant, messy pile. And that lumber is scattered all over the place. Some of it's warped, some of it's unlabeled.
Some of it has been rotting in a digital warehouse since 2021. It's in forgotten documents, old wikis, shared drives with, 47 nested folders.
Don't forget email chains, ticket systems, CRMs, Slack messages, meeting recordings. It's everywhere.
And that's the point. Your brand new, highly skilled synthetic agents can't build anything with lumber they can't find. Or worse, with wood that's completely rotted.
And this is where we run straight into one of the most dangerous dynamics in AI today. The book calls it the GIGO Amplifier.
GIGO. Most of us know that one, right? Garbage in, garbage out.
A classic computing concept. In the old world, you put bad numbers into a spreadsheet, you got a visibly bad result.
The calculation was obviously wrong, the report had an error, and a human caught it. There was a warning flag.
That warning flag is gone. It's completely gone with AI.
So what happens now?
AI doesn't produce visibly bad outputs. It produces outputs that are, well, they're confident, they're fluent, they sound authoritative.
And all from absolute garbage data.
Exactly. Think about that. The sentences flow perfectly, the grammar is flawless, the conclusions sound so reasonable. They might even look like they came from a high-priced consulting deck.
But there's nothing in the presentation that flags, hey, warning, the entire premise of this analysis is based on a document that was retired 2 years ago.
So we're not talking about GIGO anymore. We're talking about
The GIGO Amplifier. Garbage in, confident garbage out.
And the danger here is just fundamental to how these models work. They're not thinking. They're using incredibly complex math to predict what words should come next.
Based on patterns in the data they saw.
Right. And they have absolutely no mechanism, zero, to check those patterns against objective reality. If the input data is wrong, the prediction is just confidently wrong.
This is a huge danger for you, the listener, because all of your instincts are calibrated for visible errors. You know when a spreadsheet is broken.
You do. But when an agent you've hired to be an expert delivers a perfectly written, authoritative, but completely false premise, what do?
You act on it. And the consequences could be catastrophic.
Imagine a synthetic researcher producing a flawless market analysis. Looks great, but it's based on an internal document that was invalidated a year ago.
The executive acts on that confident garbage. That is so much worse than not having the agent at all.
It is. The source puts it very bluntly. An agent without data is a brain in a jar. It can think, but it cannot act.
An agent with bad data is worse. It acts confidently on false premises.
So that's the stake. The data determines the ceiling.
Okay, so if the data is that important, what makes it good? We have to go beyond just clean it up. We need a framework.
And the book gives us one. The 7 dimensions of data quality. A failure in any one of these degrades the entire output. This is the audit checklist that most organizations have just never run.
All right, let's walk through them. Where do we start?
We start with the first dimension, quantity. The question seems simple.
Do you have enough data?
Do you have enough data to cover the entire domain the agent is supposed to operate in? Because if you don't, you create blind spots.
The agent doesn't know what it doesn't know.
That's it. So take your example. Your knowledge base covers 80% of your products, but it ignores the other 20%, the legacy stuff.
So the agent will just say, I don't know, for that 20%.
No, that's the problem. It will hallucinate answers for that 20% because its core job is to generate a fluent, confident response, always.
So the takeaway isn't just go get more data.
No, it's get enough data for the use case, match the quantity to the required expertise.
Okay, that makes sense. Dimension 2.
Accuracy. Is the information actually correct? This one feels obvious. but it's where errors get amplified by that AI confidence we talked about.
So if it's a single wrong number in a spec sheet,
Your synthetic developer might use that to generate hundreds of lines of bad code. And outdated policy becomes advice that violates current compliance.
and data rots, right, was accurate in 2022 might be dangerously incomplete by 2025. You have to keep verifying it.
Constantly. Which brings us to the next one, bias.
Is the data representative?
Exactly. Is it representative of the world or just your historical customer base? If your customer data skews heavily to one demographic,
Your AI's recommendations will also skew to that demographic.
and bias is so tricky because it's often invisible. It just matches the assumptions already baked into the company.
So the question you have to force yourself to ask is, does this data represent the full range of cases or just the ones we've always focused on?
Which leads right into dimension 4, diversity. This isn't about demographics, it's about scenarios.
So, edge cases, variations.
Yes. Does the data cover edge cases? If your training data is only the happy path, the standard easy scenarios, your agent becomes useless the second an unusual request comes in.
The long tail matters more for AI than for a human just looking something up.
Much more. You have to deliberately include exceptions, failure modes, all the weird stuff. Otherwise, you get dangerously narrow capability.
What's number 5?
Number 5 is curation. This is the big one. Is the data clean, organized, and labeled?
This is that back-breaking work nobody wants to do.
And it's the work that makes everything else possible. This is where you transform that pile of lumber into a framed structure.
Because if it's just an unstructured mess, say some specs are in a Word doc, some in a PDF, some in a Slack thread,
The agent can't parse it. It can't tell the difference between an official policy and someone's draft notes. Poor curation means poor retrieval, period.
okay, 6.
Timeliness. Is the data current? Stale data produces irrelevant answers.
Last year's pricing guide.
Exactly. Or docs for a retired product. The agent just retrieves what matches the query semantically. It has no idea one is current and one is historical.
So you need versioning, expiration dates, that kind of thing.
You have to. And finally, dimension 7. Privacy and security. Is the data properly protected?
Because AI access amplifies the risk of exposure.
Massively. An agent with access to sensitive data health information, executive salaries, could inadvertently surface it to the wrong person if your controls aren't perfect.
GDPR, IPA, all that still applies.
It all still applies. You need strict role-based access controls, audit logs, data classification. If you miss even one of these 7 dimensions, your confident synthetic worker is acting on a flaw. So we've defined quality, we've organized the lumber. What's next?
Now we have to wire the building. We have to connect the agent's brain to the data. And that system is Retrieval Augmented Generation. RAG. It's the agent's nervous system. It's what connects it to your proprietary knowledge.
Because without it, the base LLM is totally blind to your company's internal world.
RAG is an architectural choice that solves 3 huge limitations of these models. First, knowledge cutoffs. A model like GPT-4 doesn't know what happened last quarter. Its training is stale.
Second, hallucinations. We've talked about this. Without being grounded in facts, it just invents things.
And third, maybe the most critical one for you, is the lack of proprietary knowledge. The base model knows nothing about your customers, your processes, your history.
It's an expert in the world, but a total novice inside your company. But when you implement ARG, you solve all 3. The system. It works like this. Instead of just using its old training data, it first searches and retrieves relevant, verified content from your internal knowledge base.
And then it uses that content to generate an answer.
A grounded, cited response. And this is incredibly powerful. The sources show that a well-built RGA system can lead to a 71% reduction in hallucinations.
71%, that's a huge number, but why not 100%?
That's a question.
Yeah.
Because the remaining failures usually come from one of 2 places. Either the retrieval system pulled the wrong source,
Right.
or the source it pulled was flawed. A failure in one of those 7 dimensions we just talked about. If the source itself is inaccurate, the grounded answer is still bad.
Okay, let's get into the tech a bit. What makes ARG work is something called semantic search or vector search.
And this is totally different from the keyword matching we've all used for 20 years.
In traditional search, if I type login, it looks for documents with the word login. It's very literal.
Very literal. But think about this. To a traditional search engine, reset my password and forgot my login are two completely different phrases.
To a human, they mean the same thing.
And to vector search, they do too. It converts the meaning of text into numerical vectors. Think of them as points in a conceptual space. Then it matches meaning, not keywords.
It understands that reset password and forgot login are conceptually close, even if the words are different.
That's it. It dramatically improves retrieval accuracy. It lets agents reason about concepts.
But just installing a tool isn't enough. There are implementation imperatives.
3 big ones. First, data preparation. You have to filter out the garbage before the algorithm find it, and you have to chop up huge documents into smaller, retrievable chunks.
Second is security and access. This goes right back to dimension 7.
You have to use strict role-based access controls. It is just unacceptable for a support agent to be able to retrieve executive compensation data by accident.
And third, governance.
Governance. Someone has to own this substrate. You need controlled changes, clear ownership, constant quality measurement. Without it, your beautiful knowledge base turns right back into that pile of rotting lumber.
So that's the theory. But the enterprise reality is, well, it's a lot messier.
The polite way to say it is that organizations have fragmented information. The brutal truth is that data silos are the default state.
That knowledge is split across everything. Documents, wikis, CRMs, email, chat.
And every silo has its own history, its own gatekeepers, and a huge collection of what the book calls orphans. Data nobody maintains, but everyone still relies on.
And you're fighting against history. Legacy formats like scanned PDFs, databases with no documentation.
The older the company, the deeper the archaeology you have to do just to get the data into a machine-readable format.
Then you have the permissions minefield on top of all that, and you have to do it all at scale. Millions of documents, thousands of users, sub-second latency. It's hard work.
The source is crystal clear on this work we're about to describe. It is 80% of the effort and 0% of the glory. But you can't skip it.
So there are 5 essential phases. What's phase 1?
Phase 1, map. You have to inventory the silos, find out where the knowledge actually lives, identify those orphan sources. You can't fix what you can't see.
Phase 2, clean.
Remove the garbage before it becomes confident garbage. Delete outdated content. Resolve contradictions between documents. Every contradiction you leave is a future hallucination waiting to happen.
This is the worst job in the digital world.
But the most essential. Then phase 3, label. Structure the data for retrieval. Use metadata, categories, tags. An unlabeled document is basically invisible to your agent.
Phase 4, govern.
Define permissions. Implement access controls. You have to focus on appropriate access. Who should see this, not just who can see it.
And finally, phase 5, expose. This is where you actually build the pipelines and deploy the RAG architecture to make the whole thing usable.
And that's the key. The data substrate, when you treat it right, is a massive asset on your digital balance sheet. It appreciates with curation.
And it depreciates with neglect.
Rapidly. The people who skip this work, this digital carpentry, are the ones who end up blaming the models or the vendors when the real cause was just bad inputs.
It's the absolute truth. Your AI can only be as smart as the data it can see. The model quality doesn't matter if the input is garbage.
So let's synthesize this. 3 governing principles from today. First, the substrate determines the ceiling.
Second, the 7 dimensions define quality. Quantity, accuracy, bias, diversity, curation, timeliness, and security. A failure in any one creates a different kind of problem.
And third, wiring the building, the RAG architecture, is not optional. It's what grounds your agents in your reality.
Okay, we've established the floor, we have the materials, we have the structural foundation, but right now we just have isolated agents. They need to coordinate.
With each other, and just as critically, with your human teams. So next time we move on to Chapter 6, the nervous system.
We're going to explore the workflow layer that turns these smart, isolated agents into a truly coordinated capacity.
Getting them to work together and with us.
Join us then for the next deep dive, where we see how to operationalize synthetic teams.